want to look at how can we find Macaulay duration for a bond with annual coupon payments. We'll then later look at how do we find the Macaulay duration of a bond with non-annual coupon payments. So let's first look at what do we mean by Macaulay duration. So what does Macaulay duration mean? So it's a weighted average time. So it's a weighted average time until the bond's cash flows are received. We'll first find it for a bond with annual coupon payments, and then we'll find it for a bond with non-annual coupon payments until the bond's cash flows are received. Here, the key is over here. Let's just look at it. The key, so we're basically looking at what Macaulay duration is, and the key over here is it's a weighted average time. Right. Okay. So before we actually proceed with this, let's just see. We're given the coupon rate. From this, let's just find the coupon amount. We know the coupon amount is the coupon rate times the face value. So since these are annual coupon payments, so the annual coupon amount is, so our coupon rate, which is 8% of the face value 1000, right? Because the coupon amount is found by multiplying your coupon rate with your face value. So 8% of 1000 is $80. So this is the annual coupon amount you receive for 3 years because time to maturity is 3. Now let's actually proceed with how we will solve this question. So we'll basically make a table in order to find the Macaulay duration. So let's start. Our first column will be T in years. Okay, so let's just make it slightly over here. So sorry, my bad. Let's just make it a little over here. T in years, right? Where T is basically going to denote, T is the time in years when the cash flow is received. T is the time in years when a cash flow is received. This is how we're defining T. When a cash flow, this cash flow could be, with bonds, there are two types of cash flows: the coupon payments and the face value, which is received at maturity. When a cash flow is received, so we're defining T over here. We'll fill this up later. Let's first write down all the columns. We have T, and then we have the cash flow over here. Then we'll write the cash flow that's received at each year. Then we'll have a column for present value of cash flow. We'll have a column for that, and then we will have a column for weight W, and then we'll finally have our last column, which would be W times T. So now let's fill this up. So T, like we said, is the time in years when the cash flow is received. Here, the first cash flow is received at T is equal to 1, the next cash flow is received at T is equal to 2, and then the next cash flow is received at T is equal to 3. Because it has 3 years majority, so you'll receive an annual coupon amount at year 1, at year 2, and at year 3, you'll receive the annual coupon amount as well as the face value. So now let's fill in the cash flows. The cash flow at year 1 would be the annual coupon amount $80 that we found here. In year 2, the cash flow would be the $80, the annual coupon amount. In year 3, because the maturity is 3 years, so this is the last cash flow that we want to add here. So this will be 1080. Why 1080? Because at maturity you will receive the face value as well. So at year 3, you won't just receive the annual coupon amount for that year, but you would also receive the face value at maturity, right? So here, one thing to keep in mind is to don't forget to add the face value in last cash flow, because the face value is received at maturity, and this bond did have maturity of 3 years. So don't forget to include, don't forget to include the face value, which in this case is given as 1000. Include the face value in last cash flow, right? So this is something we should not forget. Don't forget to include. Now let's find the present value of the cash flows. So how will you find, so to find the present value of the cash flows, let's draw a small over here. Let's make a small timeline over here for this, right? So let's say this is T is equal to 0, this is T is equal to 1, this is T is equal to 2, this is T is equal to 3. We know you receive 80 here, we know we receive 80 here, and we receive 1080 here. And here T is in years, right? T represents year. This is year 1, year 2, year 3, right? So T represents years. So T is in years here, right? So we have the first cash flow 80. We want to find its present value. I want to find its value T is equal to 0 today. So we have to discount this by 1 year, right? So the present value of this cash flow would be 80 divided by 1 plus the YTM is 10% power 1, right? So this is basically going to be, if we write it correct to 4 decimal places, so it's 72.7273. And then similarly, we do it for t is equal to 2. So the cash flow at t is equal to 2 has to be discounted, the cash flow at t is equal to 2 has to be discounted by 2 years, right? So it has to be discounted by 2 years because it's at t is equal to 2. So this will be discounted by 80 divided by 1 plus YTM power 2. So this would be 66.1757. And then the cash flow at t is equal to 3 needs to be discounted by 3 years, right? To bring it to t is equal to 0. So we discount it by 3 years, right? So this has to be discounted by 3 years. 10801 plus 10% power 3. So this will turn out to be 811.410. Now, the price of the bond is a summation of this present value, which is basically going to be turned out to be 950.2539. Why is that? Because keep in mind the price of any financial asset, whether it's a bond or stock, so it doesn't matter, any financial asset is the sum of present value of all future cash flows associated with the asset, of all future cash flows associated with the asset. Right, so this is something that we do need to keep in mind, right? So we found the present value of each cash flow, and when we added the present value of each cash flow associated with the bond, that will essentially give us the price of the bond, because the price of any financial asset is the present value of all future cash flows associated with the bond. Since we found the present value, so we don't need this timeline, so let's just clear it up so that it's a little less messy. So let's just clear it up. Now let's find the weights. How do we find the weights? So the weights are given to us as the weight assigned to, like we said now, Macaulay duration is a weighted average time, where the weight assigned to each cash flow is the present value of the cash flow divided by the price of the bond, because the price of the bond is essentially just the sum of the present value of all cash flows associated with the bond, right? So the weight assigned to any cash flow is going to be its present value. Let's find it. Like for this cash flow, that is received at t is equal to 1, its weight is going to be its cash flow 72.723 divided by the price, which is the sum of the present value of all the cash flows, 950.2539. So this weight is going to be, again, if you write it to 4 decimal places, 0.0765. This weight is going to be the present value of this cash flow divided by sum of present value of all the cash flows, which is the price of the bond, 950.2539. And this will turn out to be 0.0696. And this would be the present value of this cash flow, 811.410, divided by the present value of all cash flows, 950.2539. And this will turn out to be 0.8539. Now, here we will notice the summation of weights is going to be equal to 1. The summation of weights is going to always be equal to 1. So this is a good check to see that you do not make any calculation errors. So weights should always sum to 1, right? So this is a way that you can check that you did not make any calculation error, right? So weight should always sum to 1. So in this way, you can check that you did not make any calculation error by seeing that your weight sum to 1, right? Okay, now let's do the last column, which is actually going to give us Macaulay duration. So the last column, you just multiply your weights with the time. So you multiply the weight assigned to a cash flow with the time at which you receive the cash flow, right? So what you're doing is for each cash flow, we're going to multiply the weight assigned to that cash flow with the time at which you receive the cash flow. So for this cash flow, the weight assigned to it is 0.0765 into the time of this cash flow, which is 1. So this is 0.0765. For this cash flow, let me just write it a little better so that we have more space here. So this was 0.0696, right? So this is going to be the weight, 0.0696 into the time for this cash flow, which is 2. And this is just going to be 0.1392, right? So this is just going to turn out to be 0.1392. Similarly, for this cash flow, we have the weight 0.8539 into the time for this cash flow, which is 3. And this will turn out to be 2.5617, right? 2.5617. So now if we do summation WT, now we have added up all the entries in this column, we get 2.7774, which is essentially our Macaulay duration. So this is how we can make this table. You have a column for years, a T, which is the time in years when the cash flow is received. Then you write each of your cash flows received at each of the years. Then you find the present value of each cash flow. If need, you can draw a timeline for this. But since this cash flow is received at T is equal to 1, you discount it by 1 year. Since this cash flow is received at T is equal to 2, you discount it by 2 years. This is received at T is equal to 3, you discount it by 3 years. And then you find the weight assigned to each cash flow, and then you just multiply the weight assigned to a cash flow with the time at which the cash flow is received. And the summation of this column is what gives us Macaulay duration. Right. Now let's just clear this up. And what we're saying is, so Macaulay duration is, if we write it to two decimal places, is 2.78 years. Now, where does the years part come from? How do I know this is in years? That is because we calculated Macaulay duration. It's calculated as the summation, or WD is related as summation W times T, but T is in years, right? T we took in years, right? It was the time in years when the cash flow is received, right? T is in years, so Macaulay duration is in years as well. So that is why I know the unit is going to be years, because T, that is in its formula, and summation WT is in years, so Macaulay duration is in years, right? So this is just something to keep in mind.